This is question from February March 2017, 9709, variant 32. Question number 7. A water tank has vertical sides and a horizontal rectangular base as shown in the diagram. The area of the base is 2 meter square. The area of the base is 2 meter square. At time t equals to 0, the tank is empty. Means when time is equals to 0, there is no height. There's no volume. And water begins to flow into the tank at a rate of 1 meter cube per hour. So inflow 1 meter cube per hour. At the same time, water begins to flow out from the base at a rate of 0.2 into square root of 8 meter cube per second. So here outflow. So that is 0.2 root h meter cube per hour, where h is the depth of the water in the tank at time t hours. Form the differential equation satisfied by h and t. So we're looking for the relationship between h and t, the differential equation satisfied by h and t, the two variables, and show that the time t hours taken for the depth of the water to reach 4 meter is given by this. So it means that when height is equals to 0, that when height is equals to 0, time equals to 0, and when time is equal to t, the depth is 4. So these are the two conditions. So here what you can do, so as this rate of inflow and outflow is there, so what is the net rate? Simply subtract 1 minus this value. So what is the net rate of increase of volume? So I can write the net rate of increase as dV over dt is equals to inflow was 1 minus 0.2, which is the outflow, the rate of outflow. Also, volume is base area into height. Base area is 2, height is h. So we're looking for the differential equation satisfied by h and t. So we have dV over dt, v is equals to 2 root h. So here what you can do, you can differentiate this with respect to time. So dV over dt is equal to 2 dH over dt. Say this is number 2 and this is number 1. You can, from 1 and 2, you can combine 1 and 2. So this dV over dt can be replaced by using 1 and 2. So dV over dt, 2 dH over dt is equal to dV over dt, 1 minus 0.2 root h. 2 dH over dt. So this can be written as, so 0.2 means 2 over 10, which is 1 over 5. 1 over 5 root h. You can take LCM. 5 minus root h over 5. And next, separating the variables. So this is the case of differential equation when the variables are separable. So 10 over So as dh over dt, collect all the terms in h on the left hand side. dh is equals to dt. So after separating the variables, write down the limits. When time is equals to 0, depth is equals to 0. When time is equals to when time equals to t, when this is given the question, when time equals to t, depth is 4. So these are the two conditions given. These are the boundary conditions. When time equals to 0, h equals to 0. When time is equals to capital T, h is equals to 4. So you can write the corresponding numbers here. So we have when time is equals to 0, h is equals to 0. When time equals to t, height is equals to 4. Now, after this, what you can do, you can just leaving the left hand side as it is 1 dt, you can integrate t. The integration of 1 respect to t is t, 0 to t, which is equals to upper limit minus lower limit, and left hand side is from 0 to 4, 10 over 5 minus root h dh, and this implies t is equals to 0 to 4, 10 over 5 minus root h dh. This is that result which we want. T is equals to, yes, this is the this. Limit from 0 to 4, 10 over 5 minus root h. This is how you can do the, and then you can prove this thing. Yes, we have the first solution to the first part here. Second part is using the substitution u equals to 5 minus root h, find the value of t. So here we have t is equals to from 0 to 4, 10 over 5 minus root h dh, h from 0 to 4. The substitution is u is equals to 5 minus root h. So for in integration by substitution, what we do first, we differentiate the substitution. You can differentiate it directly, or you can, as we're looking for dh in terms of dv. So let us instead of differentiating this directly, let us make first h the subject. 5 minus u, squaring both sides, 5 minus u square. Now dh over du is 2 bracket 5 minus u power 1 into the derivative of base respect to u is 0 minus 1. So this is minus 1. So finally dh you can write minus 2. So this implies du. So dh can be replaced by minus 2 bracket 5 minus u du. U can be replaced by 5 minus root h. Now let us change the limits. When h is equals to 0, when h is equals to 0, using this substitution, when h is equals to 0, u is equal to 5. U is equals to 5 minus 0, which is equals to 5. And when h is equals to 4, so I'm changing the limits. U equals to 5 minus root of u was the minus root of h was the substitution. So u equals to 5 minus root 4. U is equals to 5 minus 2, so this is 3. So we have changed the limits as well. So when h equals to 0, the corresponding value of u is 5. When h is equals to 4, the value of u is 3. And here dh can be replaced by minus 2 bracket 2 minus 2 into 5 minus u du. And yes, so after this substitution working, let us change the variable here. Therefore, t is equals to, when h equals to 0, u equals to 5, write 5. When 4, it is 3. These are the values of u. 10 is 10 over 5 minus root of h can be replaced by u, and dh can be replaced by minus 2 5 minus u du. Now t is equals to 5 3 minus 20 5 minus u over u du. So there is a result that if you remove the negative sign, you can change the limits. So as it is previously from 5 to 3, when you remove this negative sign, it is from 3 to 5. So this is important result, which you can keep in your mind, that if there is from a to b fx dx, this is same as when you write b when we move the b in the lower limit and a the upper limit. So just change the sign. So this is important result. So the only difference that we change the sign. So here I am changing the sign, and so it was from 5 to 3, not 3 to 5, 20, and you can write 5 minus, or you can open the brackets, minus u over u, or simply you can write 5 minus u over u du. 100 minus 20u over u du. 3 to 5 the limits. Further, you can write 100 over u minus 20u over u du. Simplify further, and you have the case here that it is 100 over u du minus 20 du. 100, or you may write this 100 just for understanding, to split this integral. This is natural log of u minus 20 is 20u. And yes, the limits were from 3 to 5. And yes, t is here. Upper limit 100 natural log of 5 minus 20 into 5. Upper limits minus lower limit 100 natural log of 3 minus 20 into 3. So you can use calculator, or you may write the answer in the exact form, minus 100 natural log of 3 plus 16. Or you can use the calculator at this stage, or you may simplify for the exact answer, like 100 natural log of 5 minus 100 natural log of 3 minus 40. 100 is common. Natural log of 5 minus natural log of 3 minus 40. And next, you can further write 100 natural log of 5 over 3. There is no instruction like to write the answer in the exact form. So you may directly write the answer from here in decimals. So, or you may write this in the exact form. So time is 100 log of 5 over 3 minus 40. This answer is t is equals to 11.08256 dot dot dot. So as we write answer to three significant figure, 11.1. So 11.1 is the time, is the required time. Find the time taken. The question was find the value of t. So we find the value of t, and yes, t is here. Or you may use the calculator right at this stage and get the answer here. 100 natural log of 5 minus 100 minus 100 natural log of 3 plus 60. Yes, the answer is 11.1.